Okay, hello everyone. So before we move on to more advanced proofs, I was thinking that we should do these before we move on to other proofs like proofs by contradictions and indirect proofs and induction. I was thinking we'll do some more advanced direct proofs, and here I have two questions. In fact, let me just edit this one real quick. Divided by 4. Okay, so over here we have two questions, right? So the first being, let A, B, and C be sides of a hypotenuse, be sides and hypotenuse of a right angle triangle. Show that if the area of the triangle is equal to c squared over 4, then the triangle is an isosceles. So we're going to do this question first before we move on to the other one. So 4 there. So how do we approach this question? So in fact, what do they want us to do? Well, we know that a right angle triangle looks like this, right? Then we know that the hypotenuse is C, then the sides are A and B. Now, the area of a hypotenuse triangle is equal to 1 over 2 BA, the base and the height, in this case BA, right? So 1 over 2 BA. Now, they've also told us, say, if the area of this triangle is also equal to c squared over 4, then this should imply that the triangle is an isosceles. Now, if the triangle is an isosceles, then these two sides are equal, right? We have C there, A there, and B there. And if these two sides are equal, therefore, A and B should be equal. So this is what we want to prove, right? So how are we going to do this? Well, just going to backstep a bit there. We're going to start off with our triangle there. So A, B. So what do we know? What we know is that, first of all, the area is equal to 1 over 2 BA, right? We have this. Then we have, for a right angle triangle, we have a very famous formula, which is the Pythagoras, how do I spell it? Theorem. So Pythagoras theorem, which is basically c squared is equal to a squared plus b squared. We'll come back to this. And then we have the area that we've been provided to say area should also equal c squared over 4. Now, given this bit of information right here, right? So given this bit of information, how are we going to move on? So let's begin. So we're going to start off with our proof. So for you, just follow along. So we're going to say proof. So for our proof, right? Just going to split my screen like that so I have everything in one screen. So we know that our area is equal to 1 over 2 BA, which is also equal to c squared over 4. Now what we'll do is that we'll multiply these two equations by 4, which gives us 2AB is equal to c squared. Now, where have we seen c squared? Well, we've seen c squared in Pythagoras' theorem, which is c squared is equal to a squared plus b squared, like that, right? Now, having this, we have 2ab is equal to a squared plus b squared, like that, right? Then we're just going to move everything to one side, which then gives us a squared minus 2ab plus b squared, right, is equal to a 0 right there. Then we can go on with the factorization, but once we factor out this one, so using the sum, products, and factor, what this gives us is okay, so we have our sum here, -2, our product is equal to 1, factors is just equal to -1 and -1 there, right? So these are the only factors that we can use. So we'll have a squared minus ab minus ab, a squared minus ab plus b squared is equal to 0. What's common here? A. We have a minus b. What's common here? -b. We have a minus b left there, right, is equal to 0. We factorize these. We have a minus b is equal to 0, like that. Then we solve for any one of these. Let's just solve for a. If we solve for a, we have a is equal to b, like that. So hence we've made our proof there, you see, right? Because Since A is equal to B, the triangle is isosceles. How do you even spell this? Is isosceles. Yeah, is isosceles. Is an isosceles triangle. Yeah, since we have that there, we know that okay, our triangle is going to be an isosceles triangle, and this is how we go about this proof. So just to recap, we know that we have Pythagoras' theorem, we have this area here, and the question has asked us to say if the area, we know this, is also equivalent to this, right? It's also equivalent to c squared over 4. Then this triangle is also an isosceles. And if the triangle is an isosceles, then this side, let me just change my color, then this side and this side must be equal, right? So A should equal B, like so, right? So we do that to prove that, since we just can't state that from the beginning. We use a direct proof where we say, okay, given that we know that, so we're going to say, let's just manipulate these two formulas, we equate them to each other, because we've been told to say, we assume they are true. We've been allowed to use it, so we assume they are true, we equate them to each other, and then we just solve them like normal quadratic equations until we get to the point where A is equal to B. In that case, we've proven that these two sides are equal, and the isosceles triangle in that form, we know that these two sides are always equal. Yeah, so that's how we go about with this simple proof. So what is our next proof? Our next proof, this is under number theory, and when we start discussing number theory, we'll find a lot of proofs like this. So methods of proof is more like every topic that we do in discrete mathematics will have one proof. We'll always have proofs. We always have proofs in mathematics, in discrete mathematics. So that's more like, this one just introduces you to how we'll be proving things. Except for algorithms, which is the next chapter we're going to do, everything always has proofs here. So how we do this? Well, question 5, right? So let's look at question 5. Right, let's look at question 5. So let a, b, and r be integers and n be a positive integer. Prove that if a and b leave the same remainder, r, when divided by n, then a and b are both divisible by n. Now, if we have some now, just for some quick background here, right? This is just one thing you should remember. So when we start doing number theory, which will be our third topic, we'll dive deeper into all the different ways we can manipulate divisions, because number theory is just about divisions and remainders and all the like, right? But then, this is what we're going to do. What we're going to say is, okay, if we have a number a divided by n, this implies that a can be expressed in the form n by some number t plus r being our remainder. Mean that n goes into a t times plus remainder. So it's just the basic form you should remember for whenever you hear that, okay, a number divides another and leaves a remainder. This is all you should remember to say. If that number is a, if we divide it by n goes into a, n will go into a t times and leave a remainder r, like so. Now, how will we prove? So you know that, okay, this is a is equal to nt plus r, and then b is equal to ns plus r. Remember, these two leave the same remainder, so we can use the same value here, but we don't know how many times n goes into b, and we don't know how many times n goes into a. That's why these two here are different. Okay, then now we want to prove to say, okay, if these both leave the same remainder, then so does their difference, right? So we know this, right? So now we start our proof. Now for our proof, this is what we're going to do. We're going to say a minus b. Now we already know that a can be expressed in this form and b can be expressed in this form, right? So this guy will then give us nt, right? nt plus r plus ns plus r, right? This then gives us, in fact, nt plus r minus ns minus r, because this r, this negative multiplies everything here. So then we're going to have nt minus ns. These two over here will of course cancel out each other, so we can just skip writing them in the next step, but it will just be r minus r. Then we factorize there, and we have t minus s, which is equal to np, right? Np. Now since there is no remainder here, right, a minus b is here, right? So all this is telling us to say a minus b is equal to np, right? A minus b is equal to np, meaning we can divide, n goes into a minus b, p times, without leaving any remainder, because there's no remainder, there's no remainder over here, right? So this is the end of our proof. So this is the end of our proof, q e d, just like that. So just to recap, we know that if n divides a and leaves a remainder r, we write it in the form a is equal to n by some integer, because we don't know how many times it goes into there, plus r, our remainder. Same for b. And then since our proof is a minus b, we're going to say, okay, a minus b is equal to nt plus r minus that. Then we just do normal algebra here to manipulate that, which leaves us a minus b is equal to np, right? Once we get that, that's it. We've proven that this divides this. So once we start doing number theory, we'll have something like n divides a minus b. So we're going to go over this kind of notation, because this is basically what we have here. So this is the same as that. But again, don't worry about this. This is a later topic that we'll go dive into with more detail. But this is how you go about such a proof, and we'll do more proofs like this later on. So yeah, this is it for this kind of proof. Yeah, bye.